Actually, can I start? When you have a car that you think is safe to put on the road, who do you have to ask and get permission from to have it driving around the streets of Pittsburgh? And how does that process work? What do they do to decide?
Yeah, exactly. So in Pittsburgh currently, that whole issue is circumvented because we still have safety drivers in the car, and so we have approval from the city and the state that this is fine because this is just effectively this is a car under the control of the safety driver, and so we don't really need to change anything. How all that's going to happen once you pull the driver from the car, there's a lot left to be figured out for that.
The follow-up question is, how many interventions have you had in Pittsburgh per car per day?
Yeah, we don't really share our intervention statistics, but I can tell you sort of very roughly, like if you were to get a ride in this car, right, we're not there yet. It drives everywhere on its own, but realistically on any given trip, good chance the safety driver will take over at some point to cover something that we didn't have.
The technical question, the comment is, for folks like me who are not going to be able to drive too many years in the future, this is terrific. My kids take away my keys, I can still get around. So for the elderly among us, this is a terrific tool, and that'll become very important. And then the technical question is, why don't you maximize some function of the bias and the variance rather than just getting the single optimal? In other words, you showed those bands.
Oh, in the active optimization,
yeah.
Right.
Yeah.
Right. So that comes down to how you write down the criteria that you're trying to optimize there. In some cases, you want to. So, for example, the upper confidence bound algorithm is used to create exploration. When you're going to finally deploy a point, some people would turn that around and look at lower confidence bounds and take the max of that to actually pick your deployment point. Yeah.
So I'm going to ask a policy question, completely out of character. I live in an urban area, and services like Uber and Lyft have completely transformed the shape of what transportation is like there. And I can believe that autonomous vehicles in urban areas are going to potentially have very positive but potentially very different sociological effects than they do in rural communities. And I know that the experience of using a service like Uber in rural areas or suburban areas even is very different from what it's like for me in an urban area. And so I wanted to ask you to speculate, do you think that autonomous driving has the possibility of, perhaps as an unintended consequence, promoting suburban sprawl and promoting long commutes as commutes become less painful because they are now self-driven?
Yeah, I think that's a great question. I don't know the answer to that other than to say I've observed the same thing. As someone who hates commuting, if it suddenly became something I was willing to do, I would probably be willing to do it further. But I think the flip side of that is right now, somebody mentioned this earlier. Right now, carpooling is it's just a pain. Policy-wise, we've done everything to encourage it, but it's just not happening. And the reason is, I would carpool if I didn't have to worry about my friend showing up at my house on time. If I could just drive my car to a lot and I knew I would step right out of my car and into the carpool car, I would do it. And I think with self-driving cars, we'll get to a point where that becomes possible, that these will become like going to the bus stop, except that rather than waiting a long interval for a large bus, you'll wait a very short interval for a very small bus, and it'll just be so much more efficient, you'll just do it. Yeah.
Sorry.
So you mentioned that the self-driving cars are more aggressive. So just thinking about from pedestrian point of view. So you said that self-driving cars are more aggressive. So from a pedestrian point of view, I now tell my kids, right, when you cross the street, you look at the driver, make sure they see you, and then you cross. So what would I tell them when there's nobody driving the car?
That's right. So I want to clarify one thing. Not that self-driving cars are more aggressive, because currently our cars are very conservative, and I'm sure you've seen reports of it with the Google cars, right? Other drivers learn to take advantage of our cars because they're so conservative. My last statement about being more aggressive is a farther in the future statement. At some point, they'll become more skilled. But I think we are going, and then correspondingly more aggressive because they're good at it. And we've done nothing about this, but we've started thinking about this. What are the signaling things you would want to put on a car? You can imagine a car that has additional lights on it that have other meanings. Instead of I'm thinking about going right, here's the I see you standing in front of me light. You can imagine that there's more of that gets added and needs to be.
So to actually follow up on Greg's point earlier, I'm a part of a large study that's funded by the Texas Department of Transportation, where my role is just thinking about how cars can get through intersections, and I showed the videos yesterday of my vision of that. But part of that study is a bunch of colleagues in the Center of Transportation Research at UT Austin, civil engineers, and who've been doing surveys, finding and trying to gather information about what the impact on how far would people, how much urban sprawl would there be. They're gathering. There are. I don't have the stats off the top of my head, but there are some sort of backed up answers to those questions. Of course, you don't know how things will play out, but there is one statistic I do remember is that with car sharing and carpooling, like you're talking about, there will be some additional miles driven because there'll be some cars driving with empty driving when they're empty. But in terms of the number of cars needed to satisfy the typical demand, it's about 1/9 of the number of cars that we currently have, because most of our cars are parked almost all the time. And if they're constantly being recycled, that leads to just a much smaller need or demand for cars. And that can also change a lot about the urban infrastructure needs, and whether you need parking lots and sort of, it might attract more people to urban centers. It might cause people to spread out more. There's sort of competing factors, and people are getting an understanding of that. Some people doing surveys and stuff like that.
Mm-hmm. I don't know if there's time for seconds, but so I have another question. So this is in response to the earlier point about how do human drivers successfully interact with autonomous vehicles. I feel like this is actually the tip of a gigantic iceberg of a field, which is it's kind of like human-computer interaction, but where it's really about understanding how humans, both as individuals and societies, interact with intelligent agents and autonomous agents. And it feels like self-driving cars are an example of where this is going to be played out rather dramatically in the very near future. But I think that it's something that's sort of pervasive, and I don't know how we study that. And I was wondering if at places like Uber, are you thinking about not just how you build a user interface for your user, but actually really focusing on paying attention to how it interacts with other people and its environment?
Mm-hmm. Yeah, there's a lot of thinking now on especially the modeling for that interaction between the agents, you and the other agents on the road, and understanding how that interaction goes, how you understand what they're doing, and vice versa, and agree that you both understand. But I would say I think you used the word tip of the iceberg. We're just at the very beginning of that. Yeah. One question, by the way, that we get around Pittsburgh is what's going to happen to the Pittsburgh left.
So you mentioned that in Pittsburgh, the city approved it because you had the safety drivers there. What was the issue in San Francisco? So for those of you that don't know, just before Christmas, Uber rolled out this same service in San Francisco, and that lasted about, I think, 2 days before the Department of Motor Vehicles pulled the registrations from those vehicles. The issue was that there were some regulations in place in California for what you need to do to actually use self-driving vehicles. It was unclear what they applied to, and in particular, while Google was complying with these,
Tesla was not complying with these and driving on the same roads. And so it seemed like there was some odd sort of misapplication of this. So Uber took the position that, well, we're certainly not doing anything Tesla isn't doing, so we're just going to roll out. And of course, California took issue with that, and so that's now being negotiated with.
But there were safety drivers in San Francisco.
Yeah, it's the same thing, right? Safety drivers in the car, right? Yeah, exactly the same thing. Yeah, so it really, most of you are familiar with Uber. Travis and the others are sort of very principled about where they see regulations that they think are maybe unclear or not being applied evenly to all parties. They definitely sort of engage those, and that's what happened in San Francisco.
And this might be a completely ignorant question, but when I talk to students about self-driving cars, one of the quandaries that often comes up is the ethics of making decisions. Do you drive over the children or do you drive onto the pavement? These kinds of versions of the so-called trolley problem. Mm-hmm. And I just wondered from a kind of computational perspective how you deal with that and whether these kind of conceptualizations of trolley problems are completely wrong-headed and that the kind of ethicists are thinking about it in a completely unhelpful way.
Yeah, I think it's fine for people to think about those kinds of things. Certainly at some point we're going to have to answer those questions. The thing to keep in mind, though, is that when these cars really go live, there's, someone put the number up earlier, but there's order 40,000 deaths in the U.S. every year from cars and on the order of 1 million around the world. When these things finally go live and become and are everywhere, we are going to be saving so many lives, just an enormous number of lives that I'm sure we'll be able to find something sensible to do for the cases like this, which in fact are an extremely tiny sliver of the total number.
I totally agree with you about the net safety is potentially much, much greater, but I'm just wondering whether it's even helpful at all, or the kind of non-computer scientists amongst are completely misconceiving the problem, or whether you would conceive it like that and then you would have to think about the optimization function.
Yeah, no, I think all of that stuff will come.
Okay.
It will certainly come because those, they're extremely rare events, but they will happen.
What you would optimize.
And we'll have to think about what are we going to do in those cases.
Okay, thank you.
Great. We should stop and move on to the next speaker, but let's thank Jeff one more time.